All right, so yesterday we did examples 1, 2, and 6. We are going to go through the rest. Remember, the idea here is we have radicals, and that radicals is another term for a square root or a third root or a fourth root, which we do later in the year. But these little check marks are called radicals. Radicals will show up in our answers a lot the rest of the year. And one thing we always have to make sure is we cannot write a decimal, because that means we would have to round and our answer would not be precise. And radicals sometimes need to be simplified. So we are practicing being able to simplify a radical as simple as we can. We might still have radicals in our answer, but we want to make sure they're as small as possible. If we look at number 3, the square root of 245. Okay, I'm telling you it's not simplified, and this is something that you're going to have to get used to checking. So you have your big long list of perfect squares. It has the perfect squares for 1 to 20. So your perfect squares start from 1 and go up to 400. Okay, what we're trying to do, our skill we're trying to develop is we need to figure out which of these perfect squares can I divide out of 245? And the big misconception here is kids like to do it in flip-flop. They like to try to take a perfect square and divide it by what's under the radical. But what you want to do is you start with your radical 245 and you try to look, can I divide 245 by 400? Definitely not, because 400 is larger than 245. So you need to check perfect squares that are smaller than 245 and see which of them can be divided out. So if we look at our perfect square list, we have 245. So I go down my perfect squares. The first number that is smaller than 245 is 225. So I'm going to have to start at my biggest one, 225, and work my way down my list and see what can I divide 245 by. Now there's a lot to check, isn't there? It's a lot to check. And eventually you'll get good and be able to kind of tell. But for now, we're just going to start checking them. So 245. Can I divide it by 225? Maybe you know, maybe you don't. So you definitely can't. So if you didn't know that, though, you just type it into your calculator. 245, that's what's underneath, divided by 225. We are looking for a whole number. That is not a whole number. So that is not our perfect square. Okay, and we continue down the list. You would check 169, you check 144, you check 121. And actually, a really good thing to notice is you actually don't have to check any numbers, not just numbers that are smaller than it, but you can even just cut this number in half and check below that. So 145 in half, doesn't have to be perfect, is around 120, right? 245 cut in half is like 120. I don't even have to check anything above 120. So I could just start at 121. So we check 245 divided by 121. Does it work? No. We go to the next one. 245 divided by 100. No. Sometimes it can be tedious, but eventually we will get to 49. 245 divided by 49. And again, these are numbers for my perfect square. And what do you notice when I divide by 49? You get a whole number. That's the largest perfect square that can be divided out of 245, and that's what's going to help us simplify this radical. So 245 can be divided by 49. So we're going to write the same thing but in a different way. So instead of 245, I can write this as 49 times 5. 49 times 5 is 245. So I haven't changed my problem at all. All I've done is rewritten it in a way that's helpful. This is helpful because do we know what the square root of 49 is? Yeah, it's 7. That's why we're picking perfect squares, because we know what the square root of them are. Numbers like 245, I don't know what the square root of 245 is. And I can't just type it in my calculator because I don't want a decimal. Okay, so we continue pulling this apart, breaking it into pieces. So I'm going to rewrite it again as a square root of 49 times the square root of 5. Still haven't changed the problem. Root 49 times root 5 is still square root of 245. I haven't changed it. But now I have a root that I know. We know the square root of 49 is 7. So instead of leaving this as the square root of 49, I'm going to just turn it into a 7. That's the square root of 49. It's 7. If we know it, we should simplify to it. Do I know the square root of 5? No, I don't. That's not a perfect square. Can you divide the square root of 5 by any perfect squares? No. You can divide it by 1, but that doesn't simplify it. We can't divide square root of 5, so we just bring it down. 7 times the square root of 5 is my simplified radical. I'm done. Okay, the bigger the number, the more tedious it's going to be. Okay? But eventually you'll start to, most of our times our problems will be smaller numbers, but it's a good skill to have. So, our next one, number 4. Our number is 363. A little cheat code here is to divide by 2. This just helps us so we don't have to check as many numbers. What is 363 divided by 2? Slam it in the calculator. It doesn't have to be perfect. 363 divided by 2 is about what? What is it? 181.5. We're going to write 181. It's about 181.5. Okay, this is just, instead of having to check everything under 363, we really only have to check everything under 181. Why can we do that? Well, in order to get the perfect number 2, you would have to divide this by a number around here. So we really only have to check 181 and down. So where's the first perfect square we should start at? 169. So if we go to 169 and start testing out our numbers, we'll eventually find a perfect square. So again, this is where it gets tedious, but it just is what it is. 181, or sorry, not 181. The number underneath, 363, divided by our first number, 169. Do we get a whole number? No, that's not our perfect square. We try the next. 363 divided by, next one down, 144. Still a no-go. This is the part that's, I know it stinks, but we just have to keep going. 363 divided by 121. And boom, we get a whole number. So that is the largest perfect square I can split 363 into. Okay, so I go over here, I know what it is now, and I'm going to rewrite this instead as, what numbers would I put in here? 121 times 3. Again, it's important to understand, I didn't change anything. I just, instead of writing 363, I'm choosing to write it as 121 times 3, which is still 363. I haven't broken any math rules. I just want to write it this way instead. Okay, so continue splitting them apart into 2 separate roots. One of those radicals I know, one of them I do not know. Which one do I know? Yeah, what is the square root of 121? It's 11. And again, we're just looking at our sheet. 121 is 11. So let's write it as our whole number 11. Remember, after you take the square root, it goes away. The square root of 3, do I know that? Is that in my list? No. Can you divide the square root of 3 by any of these numbers? No, so that's already simplified. Bring it down. That is my simplified square root, simplified radical. Done. Good work, good work. Is my explanation a little clearer today? Is it a little better? I think yesterday was a little confusing. Okay, we did number 6, so if you didn't get it, it ends up being 2 root 10 if you want to have that. Oh, number 3? Number 3 was 7 square root 5.
No, wait, 4. I was trying to say.
4, 11 square root 3. Alright, just checking. Yep. Yep, we did 6 yesterday, so if you want to get that down, there it is. So our last 3 examples we do today, same thing, only you'll notice what's in front of all of our radicals. See these? We have numbers floating out in front. Okay? Now it doesn't change anything about what we do for radicals, but we do have to keep track of that number out in front. So number 5, it's whenever you see a small number, you should be like, oh, thank gosh. Because small numbers, much easier to deal with. 12 is underneath, so we go over to our perfect square list. If you want to narrow down it even more, you divide 12 by 2, which is 6. You only have to check everything less than 6. So way down here. My only 2 radicals that are smaller than 6 are 4 and 1. But remember, 1 does not help us simplify. So the only number we have to check is 4. Can you divide 12 by 4? Yeah. 12 divided by 4 is 3. So instead of writing the square root of 12, we'll write it as 4 times 3. Again, all I did was change the appearance of my radical. Instead of putting a 12, I just wrote it as 4 times 3. Yeah.
There is another way to get 12. 6 and 2.
Yes, that's true. 6 and 2 works as well, but what's the issue? Do we know the square root of 6?
No.
Do we know the square root of 2? No. So if you did split it into the square root of 6 and 2, is that going to help us simplify it? No. But it is a good point to make. There are other numbers you can divide 80 by or 250 by that aren't in our list, but we need to make sure we're picking numbers from our list so that we can take the square root. Okay, so keep breaking them up. 3, root 4, root 3. Again, I have not changed my question. I have only written it in a way that helps us simplify. Now, there's something up there I do know. What do I know? What is the square root of 4? 2. It's in our list. Square root of 4 is 2. So I'm going to rewrite this as 3 times 2 times the square root of 3. 3 times 2 times the square root of 3. If you don't like the parentheses and want to put the symbol multiply in between instead, you can do that. Now, to finish this off, I'm allowed to multiply 3 and 2 together. I'm not allowed to multiply 2 and the square root of 3 together. But anything not under a root, you can multiply together. Anything that's under roots, you can multiply together, but you can't mix and match. So 3 times 2 is 6. Bring down your square root 3. And we're simplified. 3 square root of 12 simplifies to 6 square root of 3. If you type both of those in your calculator, as different as they look, it's the same thing. It ends up being like 10.01 or something. Okay, let's go for another one. Negative 6 square root of 80. This one can be a little tricky. So what number can I start with on my perfect squares? 40. Anything less than 40. Now, if you don't like the divide by 2 trick, you could always just start with below 80, so you'd start at 64. But if you cut 80 in half and get 40, you actually don't even have to check 64 and 49. You can start at 36. So that dividing by 2 trick just helps you not have to check as many. So half of 80 is 40, so we go down to 40. 36 is smaller than 40, so that's the first one we'll check. So we divide 80, and you always start by typing in what's underneath. You don't want to flip-flop. This will turn on. There we go. 80 divided by 36. Is that a whole number? Nope. Check the next one. 80 divided by 25. Does that work? 3.2. Close, but no. Check 16. And it works. This one's tricky because 80 can also be divided by the perfect square 4. But you always want to choose the largest perfect square. Even though you can divide by the perfect square 4, it's not going to fully simplify. You would actually have to do more work if you pick a smaller one. So 16 is the biggest one. So our -6 is still floating out front. And instead of 80, what am I going to write under my radical? 16 times 5. Because 16 times 5 is 80. I haven't changed the problem, just changed the way it looks. And again, 80 is also you can divide 80 by 10, 10 and 8. But again, when you look at your list, is 10 and 8 or 8 in the list? No. You don't want to pick numbers to divide by if they're not in your list. Okay? You're always looking for your perfect square. Okay, so split them apart. -6, root 16, root 5. Just pulling them apart. We know the square root of 16. It's 4. Okay? So I have -6 times 4 with the square root of 5 stuck on the end. Which of those two numbers am I allowed to multiply together? The -6 and 4. Okay, I cannot multiply the 5 because it's under a radical, under a root. But these are just normal numbers. I can multiply those. -6 times 4, -24. Root 5. Bring it down and boom. Simplified. Nice. One more to go. I like to be sneaky and tricky. What did I do in number 8?
Just put a negative number.
No number, but what number is really there?
1.
It's a 1. Okay? Isn't it crazy how often that little invisible -1 shows up? The mathematicians just don't like to write 1s. Because when you multiply things by 1, nothing happens. They like to leave it out, keep things as simple as possible. Okay, so our number this time is 250. Now, if you go and look for all your numbers less than 250, that's a lot of numbers. You'd have to go from 225 all the way down. So if we want to narrow down our choices, we divide by 2. 250 divided by 2 is 125. So really, we only have to check everything less than 125. So we can start all the way at 121 and work our way down. 250 divided by 121. Enter. Yield, rows, 2.06. Next one. 250 divided by 100. Close, 2.5, but that's not a whole number. 81's our next one. 250 divided by 81. Getting worse. That's another decimal. Down to 64 is our next one. Remember, I'm always typing in the number under my radical first. 64. No. I'll save us the headache. What number is going to work? 25. Okay. 250 divided by 25 is our winner. And eventually you would get there. Again, sometimes it's tedious, isn't it? Kind of annoying to check all the numbers, but it is what it is. 250 will split up into 25 times 10. 25 times 10. Keep pulling them apart. -1, root 25, root 10. One of those roots I know, one of them I do not. The square root of 25 is 5. -1 times 5 times the square root of 10. 10 is definitely not in my perfect square chart, so can't really do much about him. I am allowed to multiply -1 and 5 together because they're both normal numbers, nothing attached to them, no roots, no variables. Multiply, we get -5 square root 10. And that is a simplified radical.